Okay, for this video, the first thing I'm going to state is that I'm not a chemist. I know something about it, though. I did win a chemistry award one time, but I didn't major in chemistry. I majored in mathematics and physics. But I still know something about it. I mean, so that's pretty cool, to know something about it. I'm not an expert chemist. No way. But I know something about it, and it's pretty cool. I just think it's pretty cool. There's guys that are really just, man, they're unbelievable. They can do stuff you wouldn't even believe in chemistry. And gals, guys and gals, you know. And I admire those people, but it wasn't my field of expertise. But anyway, I'm gonna show you how to. I'm gonna show people how to react diatomic nitrogen with diatomic hydrogen to create some ammonia. Okay. Now, when I say diatomic, this is how nitrogen and hydrogen occur in nature. They do not occur independently. They occur in pairs. Okay. So when I work with this, I have to use them in pairs. Okay. So I'm going to react some nitrogen with some hydrogen to get some ammonia. All right. Now, the first thing I notice is that I have 3 hydrogens here and I only have 2 here. So I'm going to do a trick. I'm going to say 2 times that equals 6 hydrogens. And 3 times 2 equals 6 hydrogens here. Whatever's on this side of the equation the reactants has to equal the products, okay? Now, let's check it. Do I have 2 nitrogens? 2 nitrogens. Do I have 6 hydrogens? I have 6 hydrogens. This is a balanced equation, okay? The first thing I'm going to do is I'm going to convert this 89.6 grams of N2 into moles. Always convert your grams into moles first before you even try to do anything, okay? Now, if you look in a periodic table, the molecular weight of nitrogen is 14, around 14. So you have to double that to get a 28 grams of nitrogen to 1 mole of that stuff. Okay. Now, the grams will cancel. And you're going to say 28 into 89.6, right? Because we got the denominator here and numerator here. Okay, 89.6. And right off the bat, I'll say 3 times. I know it's not going to be 4 because that'd be too big. So 3 times. 3 times 8 is 24. 3 times 2 is 6 plus 2 is 8. Okay, 56. 2. Okay. So what I'm going to have here is I'm going to have available 3.2 moles of N2. They don't usually put an S on there. Sorry, chemistry majors. And then for the other one, I have 10.8 grams of H2 over 1. I'll convert that to moles by saying that we have 2 grams of hydrogen for every mole. So 2 grams of hydrogen to 1 mole of hydrogen. 2 diatomic hydrogen, by the way. Okay, so grams cancel. What are we going to have left? Well, 10.8 divided by 2 is 5.4. That was easy enough. 5.4 moles of H2. So I'm going to start a new sheet stating what we have available and rewriting the chemical formula. Rewriting it. Okay. So now we have this chemical formula, which is N2 plus 3H2 plus 2, reacts to form reacts to form 2NH3, like that. So what I want to find out is what is the limiting reagent. We know that we're starting with 3.2 moles of nitrogen, 3.2 moles of nitrogen. That's what we have available. And we also have 5.4 moles of hydrogen, diatomic. Okay, remember that, diatomic. Okay, now the first thing I want to do is I want to see what happens if I use the balance equation to find out how much nitrogen I need. Always use the other one to find out how much you need for the one you're looking for. Okay, so I got 5.4 moles of hydrogen available over 1 times 3.2 moles of this nitrogen. But I'm going to use a balance equation for every 1 mole of nitrogen that I react according to the equation. I will be reacting 3 moles of hydrogen with that. Bingo, what's going to happen? The moles of hydrogen are going to cancel out of the equation, and we're going to have how much nitrogen I need. So 3 into 5.4 goes, let's see, 1.24, 1.8. Okay, so when I react it, in this reaction, I will react to get 1.8 moles of nitrogen. But how much nitrogen do we have originally available? 3.2 moles, right? So we got a whole bunch of this nitrogen. According to the balanced equation, all you need is this 1.8 moles of this nitrogen. So my guess is that the other element will be the limiting reagent. The hydrogen will be the limiting reagent, right? That's my guess. So let's check it. Okay, just to be sure. Okay, so you got 5. Let's start out with a 3.2 because I'm checking the other one now. Okay, so you have 3.2 moles of this nitrogen, and you want to find out how much hydrogen you need. So you have to react 1 mole. 3 moles of this hydrogen has to react with 1 mole of the nitrogen for the nitrogen to cancel out. So you got hydrogen left over. So basically you're going to have 9 moles. Well, 9.6 moles. 9.6 moles of H2 is required. That's what's required. Use the empirical formula to find out what's required. Okay, this is required. 9.6 moles of hydrogen, diatomic hydrogen, 9.6 moles of diatomic hydrogen, 9.6 moles of diatomic hydrogen is required. Okay, to do a full reaction. But according to what you don't have 9.6 moles, do you? You only have 5.4 moles available. So therefore, hydrogen, diatomic hydrogen, is the limiting reagent. Okay? Hydrogen will be the limiting reagent because you only have 5.4 moles of hydrogen available to complete that reaction, right? Well, now that we know that information, okay, we're going to check something else. We're going to find out how much actually we can make. What are we going to use to find out how much we can make? We're going to use the limiting. Always use the limiting to find out how much you can make, okay? So you use the limiting reactant. I'm going to use a limiting reagent to find out how much of that ammonia I can make if I just have 5.4 moles of hydrogen. Okay, so I'm going to rewrite this equation. I'm going to say N2 plus 3H2 reacts to form NH3 with a 2 in front of that. Okay. Let me write that again. NH2 plus 3H2 reacts to form 2NH3, like that. Okay, and I know from my calculation that I only have 3.2 moles. I have 3.2 moles of nitrogen, 5.4 moles of hydrogen. But from my limiting reagent calculation, I found that I am going to run out because what's required is this 9.6 moles of hydrogen is required. Okay. So what do I do? Well, I look at my empirical equation and I put down this 5.4 because I want to find out how much of this ammonia I can make with just the 5.4 moles, like that, over 1 of hydrogen, times, according to my empirical equation, I will have to react for every 2 moles of this NH3, I'm going to have to react 3 moles of hydrogen. Okay, so 3 moles of hydrogen, like that. So what do? I multiply this 5.4 by 2/3, and that should give me the answer to my question. Okay, so 10.8 divided by 3. I get 3.6. So the answer is going to be I will produce 3.6 moles of the ammonia. Okay? And I can't make any more than that because I only have this 5.4 moles of hydrogen, which is my limiting reagent. That means it's going to run out. It's going to run out. The hydrogen will run out before the nitrogen will. And the only way that I couldn't see that just by looking at it like that, I had to actually use the chemical equation to figure out what is limiting and what is in excess. And I found out that even though it looks peculiar, it looks like that, wow, you got way more hydrogen than you do nitrogen. No, according to the chemical equation, if you mix these chemicals, you're only going to be able to make 3.6 moles of ammonia, okay? But if you had this total 9.6 moles of hydrogen, which is required by the equation, then you could make a lot more, okay? That's basically how it works.